In 2000, China had 0% of the global tunneling machine market. 0. The West had spent 150 years building that technology, perfecting it, protecting it, and China had none of it. By 2024, 7 out of every 10 tunnel boring machines on Earth were made in China. How does a country go from nothing to everything in 20 years? The answer isn't money. It isn't luck. It's 7 machines that engineers in the West said could not exist. And today, we're going to show you all of them, starting with the one that literally eats mountains, the tunnel monster. Picture a machine 15 meters wide. That's taller than a 5-story building. Now imagine it spinning through solid rock 24 hours a day without stopping, not pausing for weekends, not slowing down for weather, just grinding endlessly through the earth. This is China's CRCHI tunnel boring machine. And here's the number that stops Western engineers cold. In the United States, tunneling costs roughly $50 million per kilometer. In China, using this machine, the cost drops to $10 million. Same tunnel, same rock, same depth, 1/5 the price. But cost isn't actually the most impressive part. The most impressive part is what's happening inside the machine, because in many ways, it's alive. Every CRCHI TBM runs an intelligent control system that monitors over 2,000 data points simultaneously. Cutter pressure, ground density, vibration levels, soil composition. The machine reads all of it in real time and adjusts itself automatically, like a surgeon making micro-corrections mid-operation. No waiting, no human input required. When China needed to tunnel beneath the Qiantang River under a busy, densely populated city, this machine completed it with ground settlement of less than 3 millimeters. To put that in perspective, that's the thickness of 2 stacked pennies. The city above barely felt it. The West had called this level of urban tunneling precision impossible, not difficult, impossible. China did it on their first try. And that's the thing about these machines. They don't just do what was expected, they do what was ruled out. But tunneling underground is only one dimension of China's engineering push. Because the next machine doesn't go underground at all. It walks across canyons. The Iron Monster. Imagine you need to build a bridge across a canyon so deep and wide that conventional cranes can't even reach the other side. In the West, engineers would spend months assembling temporary scaffolding. Massive steel structures, essentially full buildings built just to build the real thing. Hundreds of workers, enormous cost. All before a single permanent beam goes down. China built a machine that skips all of that, but it does. Relentlessly, China has already used the Iron Monster to build over 30,000 kilometers of high-speed rail bridges. A number so large it barely registers as real. What once took decades now takes years. What took years now takes months. And just when you think you've seen the limit of what a machine can accomplish, China built one that makes the Iron Monster look small. Kunlun, the mountain mover. The Golden Gate Bridge took 4 years to build. It stretches 3 kilometers across San Francisco Bay. It's considered one of the great engineering achievements of the 20th century. China built a 15-kilometer cross-sea bridge, 5 times longer, in less time. The machine that made it possible is called Kunlun, named after one of Asia's greatest mountain ranges, and it earns that name in every single operation. Kunlun can lift and precisely position 1,000-ton box girders. To understand what 1,000 tons means, a fully loaded Boeing 747 weighs about 412 tons. Kunlun is handling more than double that, on a slope, on a curve, over open water, and placing it within millimeters of where it needs to be. No machine in the world could do this before Kunlun was built. But here's the detail that genuinely surprises engineers who study it. Despite being designed to handle loads that would collapse most structures, Kunlun itself is built from high-strength steel plates used in aviation and submarines, the same material that keeps fighter jets in the air and submarines intact under crushing ocean pressure. This makes Kunlun lighter than traditional machines in its class, while being exponentially stronger. Laser navigation guides it autonomously through tunnels where visibility is zero. Real-time sensors track every millimeter of girder movement, from lift to placement. Automated systems communicate directly with railway engineering centers to confirm alignment before anything is set. The result: construction costs reduced by 20%, erection speed increased by 25%, and a footprint smaller than conventional machines, meaning it can operate in the tight, complex terrain of Western China's mountain railways, where older equipment simply cannot go. On the Fuzhou Xiamen Railway, Kunlun completed the first ever cross-sea erection of 1,000-ton 40-meter girders in history. That bridge, nearly 15 kilometers long, was finished faster than it took to build the original 3-kilometer Golden Gate. You've now seen what China can do underground, across canyons and over open water. But what about straight up? The machine that builds skyscrapers. In 2015, a construction company in Changsha completed a 50-story skyscraper in 19 days. Not 19 months, not 19 weeks, 19 days, 3 floors per day. When the footage came out, Western engineers called it a stunt, a publicity exercise. They said the building couldn't be safe, couldn't meet code, couldn't possibly be real. Then they looked at the structural data and went quiet. The building used prefabricated modular construction. Every wall panel, floor section, and structural element manufactured off-site, in controlled factory conditions, engineered to tolerances tighter than most bridges. Each of the 2,736 individual modules was built to fit the next one perfectly, like the world's most precise Lego set. On site, the job wasn't construction, it was assembly. But at skyscraper scale, even perfect modules need something to lift, align, and place them. That's where the Bonot comes in. The Bonot is a 2,000-ton wall-climbing construction platform. It wraps around a building under construction like a mechanical exoskeleton, a giant frame that moves with the building as it rises. It lifts prefabricated panels. It aligns steel beams to millimeter accuracy. It handles multiple heavy lifts simultaneously. And when a floor is complete, it climbs itself to the next level. No disassembly, no repositioning, no external crane required. Hydraulic jacks and counterweights maintain perfect balance during the climb. Automated controls adjust for wind load, structural shifts, and weight distribution in real time. Advanced sensors monitor stress and tilt on every part of the frame, preventing errors before they can happen. The Bono can operate in hurricane-force winds without pausing. 1 floor every 4 days, continuously, automatically. The machine doesn't sleep, doesn't stop, doesn't wait for the weather to improve. Built from high-strength, lightweight materials, the same class of materials used in aviation engineering, the Bonot's frame features redundancy systems and stabilizers that allow it to perform multiple heavy operations at once while keeping workers protected in an enclosed cabin far from the exposed heights. Western construction stops for weekends, for weather, for holidays, for heat waves. The Bonot just keeps climbing. That 50-story tower in Changsha wasn't a stunt, it was a preview. 5 years later, when COVID-19 hit and China needed a 1,000-bed hospital in Wuhan, in 10 days, the same principles and the same machines made it possible. Over 7,000 workers in rotating shifts, never stopping, guided by the same prefabricated modular system. And the hospital was fully operational in under 2 weeks. The West watched and called it extraordinary. China called it a method. The Pump King building tall creates a problem most people never think about. How do you get wet concrete to the top? At 300 meters, most pumps in the West begin to struggle. At 500 meters, conventional systems fail entirely. The concrete either sets in the pipes, loses pressure, or simply can't be pushed that high. When workers needed to pour concrete for the Shanghai Tower, a building that rises 632 meters into the sky, China's Sany pump shattered the world record, sending wet concrete 621 meters high, higher than the Eiffel Tower, in a continuous pour. The pump earned its nickname immediately, the Pump King. Its boom has 7 sections, longer and more flexible than the 5 or 6 section designs used everywhere else. This lets it reach confined urban sites and awkward geometries that would stop a conventional pump. The boom itself is constructed from 1,800 megapascal high-strength steel, the same grade used in aerospace applications, maintaining structural stability under the enormous pressures required for extreme high-rise pumping. The machine is mounted on a 9-axle all-terrain chassis with advanced suspension and multiple steering modes, including crab steering and diagonal steering for maneuvering in tight city environments. One-touch deployment extends the full boom automatically. Advanced stabilization reduces boom vibration by 50% during operation. A self-diagnosis system monitors over 150 potential fault types in real time, alerting operators before problems develop into failures. The piston itself can handle 25,000 to 30,000 cubic meters of concrete before needing replacement, enough for dozens of major high-rise projects. Energy-saving technology cuts fuel consumption by 10% compared to previous generations, while operational efficiency improves by 25%. As of 2024, the Sany pump holds the Guinness World Record for the longest truck-mounted concrete boom ever built. It has redefined what is possible in high-rise construction, not just in China, but globally. The track layer. China's high-speed rail network stretches over 40,000 kilometers. It was built in roughly 2 decades. That's more high-speed rail than the rest of the world combined, built faster than any rail project in history. None of it would exist at the pace it does without the CYP 500 track-laying machine. The CYP 500 can lay 2 kilometers of track in a single day. It operates 24 hours straight, integrating track laying, alignment, and precision placement into one continuous automated workflow. Rails are positioned with millimeter-level accuracy. The machine handles complex curves, long bridges, and tunnel sections without slowing down. In March 2020, the CYP 500 made its international debut on the China-Laos Railway. In a single operation in Vientiane, it installed a 500-meter steel track, the longest steel track installation outside China in all of Asia, and then exceeded its own daily target of 1.5 kilometers. Completing the day's goal ahead of schedule. In just 4 years, CYP 500 technology increased China's track-laying capacity from 500 meters per day to 2 kilometers per day. That is a 4 times improvement in efficiency in less time than it takes most Western infrastructure projects to finish the environmental review stage. Which of these machines surprised you the most? Drop it in the comments.